friends in my class, friends down the hall, any students, teachers, parents that want to benefit from these videos. I started these videos to review what we've learned in 5th grade during the quarantine time for my students, but I'm making them public in case anybody else wants to learn from them during this time. It's only fair that all students are learning, so please like, share, and subscribe. Let's get as many people learning as possible. Today I'm going to cover strategies for subtracting mixed numbers. So some of the videos that I've made already that are going to help you out are making equivalent fractions and adding and subtracting fractions with unlike denominators. Those two things are really important to get to the 5th grade standard, because when we subtract mixed numbers, you're going to have unlike denominators and you need to know how to deal with them. When I do this video today, I'm going to focus specifically on the subtraction strategies with mixed numbers, so I'm not going to go through unlike denominators. But if you notice that you don't have the same denominator, you know that you've watched those videos. If you're in my class, I've made you. So you know that you have to do your equivalent fraction box, make equivalent fractions, and then you can subtract once you have common denominators. So make sure you check those videos out first in case you get into a situation where you have unlike denominators. So let's get started. What I always like to think about is having what we would do with whole numbers to subtract, and that helps us when we're thinking about strategies with mixed numbers. So parents, as you know, students learn things a little bit differently. That includes how they subtract, and I want them to bring in those strategies. The standard algorithm we're going to have to set aside. They learned other strategies and they're going to use them during this time. So let's say that we have 63 minus 47, showing you with whole numbers first, okay? And we'll call our difference here m. So one thing that students might do in whole numbers is start with 63 and then subtract in parts. So something students might do is they might subtract all of the groups of 10 first, minus 40 to land on 23. And then they might say, okay, I'm going to subtract 7. So 23 minus 7 is 16. And when we get to our answer here, they know that their answer is here in this strategy. Okay? For some students, and this is what's going to happen with fractions, they might break this down even further. So they might subtract 40. They know that the tens place is the only place that's changing because there's a 0 in the ones place. And then they might say, well, it's really difficult for me to switch decades, so first I'm going to subtract 3 so I can land on 20. I like to draw a smiley face there because 20 is a friendly number that you might want to work with. So far they started at 63, subtracted 43, and they know they have to subtract a total of 47, so they're going to subtract 4 more. And those might be the steps that they take because working with this number, with this smiley face, is easier for them. Okay, so that's one strategy they might do in this situation, and I'm going to go over that with fractions in just a second. One thing that they're going to be tempted to do, and boys and girls, don't do this when you're subtracting. Do not, okay? One thing they're going to be tempted to do is break both numbers apart. In that last strategy, I did not break 63 apart. I kept it whole. I kept it all together. If they try to do that, they're going to get into situations like this. 60 minus 40 is 20. 3 minus 7. And we're not there yet. We're not thinking about negative numbers in 5th grade. We're not going there. Okay? Another thing that kids like to do is they say, well, I can't do 3 minus 7, so I'm just going to do it this way. And obviously that also gets us to the wrong answer. So we want to make sure that when we are subtracting back that do not break up both numbers. Okay, so that's what not to do. So let's get into what happens with mixed numbers. So we're going to start with 3 and 4/8 minus 1 and 5/8. Okay, I'm going to draw that same number line. And we're going to practice subtracting back on the number line. We have 3 and 4/8 that we're starting with. We are not breaking up both numbers. We are keeping 3 and 4/8 whole, all together. Nice and friendly little family over here, not breaking up. So what we are going to do though is we're going to subtract 1 and 5/8 in parts. So a good way to break it up is let's take out the whole number first. So I'm going to do 3 and 4/8 minus 1 so that I'm at, oh, sorry, not there. I'm at 2 and 4/8. Students know that the 4/8 isn't changing. We're just doing 3 minus 1 is 2 and the 4/8 comes back in. Now, it might be challenging for our friends to subtract 5/8 here because we see 2 and 4/8. So just like I showed with whole numbers, we're going to jump to a friendly number. And when we have fractions involved, our friendlier numbers are numbers that are whole numbers. So we really want them to be using and jumping to whole numbers because that's something that they feel comfortable with. It's more efficient, they can do it quickly. So let me show you what we're going to do. We're not going to subtract 5/8 all at once. We are going to say, well, I know if I take away 4/8, I'll be left with a friendly number, which is the whole number in this case. So we're going to subtract 4/8. I made this jump a little smaller, should be a lot smaller. It's half the size. Okay, so I'm going to make a smaller jump to show that I'm subtracting less. So 2 and 4/8 minus 4/8, we would land on 2. So how much have we subtracted so far? We started at 3 and 4/8. We subtracted 1 and 4/8, and now we're at 2. So what's left to subtract? I need to get to 1 and 5/8. So there's 5/8 more to subtract, or sorry, 1/8 more to subtract, 1/8 more to subtract to get to 5/8. Okay, so now students are going to feel more comfortable saying, well, I know a whole is 8/8. If I subtract 1/8, I am at 1 and 7/8. So what did we do? We started by keeping this number whole. It's over here. We subtracted 1 and 5/8 all together. I subtracted 1, then I subtracted 4/8, then I subtracted 1/8. What's important when we're working with the number line is finding where our answer is. So, where is our answer? Where is 3 and 4/8 minus 1 and 5/8? The answer is what we've landed on once we've done all the subtracting. So it's 1 and 7/8. That's where our answer is in this strategy. So when you subtract back in parts on the number line, you're going to find your answer where you land on at the end. Okay? So that's one strategy, subtracting back in parts. Another strategy that I like so much better is adding up. So let me bring back our whole number situation. What was it again? I don't even remember. It's 43. 63 minus 47. 63 minus 47. Should write this stuff down. Okay, so we know that there's a relationship between addition and subtraction. So one way that I could write this is 47 plus something equals 63. So let me show this with whole numbers, the strategy, and show you where we would find our answer. So if we were doing adding up with whole numbers, we would start over here with our smaller number, and we're going to add up till we get to 63. And this number here is our difference between these two numbers. And notice I'm saying that the word difference because when we subtract, we're finding the difference between the two numbers. When we add up, we're also finding the difference between these two numbers. So the distance between 47 and 63 is what we're going to show right now. So 47. Kids are going to want to jump to a nice friendly number, a number with a 0 in it. They know to add 3 to get to the next group of 10. I do that in class all the time. So anyways, 47 plus 3 would get you to 50. Now, very simply, they say, all right, well, I know I need 13 more to get to 63. Okay, this number that they jump to is friendly. They know how to work with it. It goes quick. It's efficient. We encourage that. So where do we find the answer in this strategy? And we're going to do it with the mixed numbers in a second. Don't worry. So where do we find that? We're going to find it right here. We started at 47. We added 3 to get to 50. and then we added 13 more to get to 63. So what is the distance between these two numbers? We find it up here in the jumps that we made. So the distance, or the difference between 47 and 63 is 16, and we see it here. Okay? With whole numbers, they're jumping to numbers that are friendly for them. They're using what they know about 10. 7 plus 3 is 10. That's what we want them to be doing. With fractions, just like I was showing you before, we want them to be making those whole numbers. Okay, so let's find the difference, or the distance, between these two numbers. Instead of thinking about it as 3 and 4/8 minus 1 and 5/8, I'm going to say 1 and 5/8 plus what is the same as 3 and 4/8. So I'm going to be trying to find the distance between 1 and 5/8 and 3 and 4/8. Since we're starting here and adding up, we're starting at this end. When we're subtracting back, we start at that end. So I'm going to start with 1 and 5/8. And our goal here is for our students to jump to those friendly numbers. So really important for them to know how to make a whole. When we're talking about eighths, we want the numerator and denominator to be the same. So to make the next whole, they should know, after watching all my videos especially, changing the improper fraction to a mixed number will help you understand this as well, that video. We're going to add till we get to the next whole. So how are we going to get to the next whole? Let me illustrate it quickly down here in case anyone missed that video. 1, 2, 3, 4. If I have 5/8, in order to make the next whole, you can see that I clearly need 3 more eighths. So we want them to get to that nice friendly number with fractions, and that's the whole numbers. Okay, so they're going to add 3/8 to start, and now they're at 2. Okay, so what do we have? What has happened so far? We know that 1 and 5/8 plus 3/8 gets us to 2. Are we there yet? No, we're not there yet, so we have to add more so we know how far, what the distance is between the two numbers. So some kids are going to want to break it. You can add everything else that's left if you're ready for that, but they might want to just add a whole number here and get to this whole number. So 2 plus 1 gets me to 3. So far I've added 1 and 3/8, but I'm not there yet, so I'm going to add the last little part here to get to 3 and 4/8. No, too many numbers going on. 3 and 4/8. So when I think about what is the difference between these two numbers, what is the distance, my answer is in a different place than it was in the first strategy I showed you with mixed numbers. It's up here. This is the total jumps I've made. So to get from 1 and 5/8 to 3 and 4/8, I had to add 3/8 plus 1 plus 4/8, which is, so 1 and 5/8 plus m is 3 and 4/8. What is the number that belongs here? 1 and 7/8. And that is the same answer we got up here. Okay? So next I'm going to do one more example. I'm going to go over subtracting back in parts. I'm going to go over adding up in parts, and then my students, you're going to try your work. And you're watching this video before you try your work, I'm hoping, as a reminder. All right, so both strategies. Here we go. Review of the whole lesson. Let's say you're starting with 7 and 1/4, and I'm having you subtract 3 and 3/4. Let's go over subtracting back first. And you should be thinking about what I'm going to be doing while I'm teaching this video. Okay, start thinking about it. So I want to subtract 7 and 1/4 minus 3 and 3/4. So what do I want to do? Perhaps I want to subtract the whole number first. I'll just keep it consistent. Some of you get more creative with where you start, and that's fine. So I'm going to subtract 7 and 1/4 minus 3. 7 and 1/4 minus 3 wholes will get me to 4 and 1/4. Nothing changes with the fraction. We're just subtracting the whole numbers here. So far I've subtracted 3. I want to subtract 3 3/4. So I know I have 3/4 left to go. However, I want to make this a whole number to work with. I don't want to mess around with this mixed number right now. So I'm just going to subtract 1/4 here so that I can be at my whole number that I like working with. So far I've subtracted 3 1/4. I know I need to do 3 3/4 total. So in my head I know that there's 2/4 more to go. And if I have 4 holes and I take away 2/4, I'm down to 3 holes. And 4/4 minus 2/4 is 2/4. So where is my answer when I subtract back in parts? When I subtract back in parts, my answer is down here. 3 2/4 is the difference between these two numbers. Okay? Now I'm going to show you in black marker how to add up in parts. So right now I'm asking myself 3, oh, I can't write it like that because then it's too close. Right now I'm asking myself 3 1/4 plus something will get me, 3 3/4 plus something will get me to 7 1/4. And my goal is to find out what is that something. Okay, so since we're adding up, we're going to be going this way. And we're trying to find the difference between the two numbers. So I'm going to start with 3 3/4. Like I was saying, let's get to that friendly number. Super easy to get there. We know 3/4 plus 1/4 will get us to a whole. So we have 4 holes now. And some of you friends are ready to just do this all at once. You're going to add everything else that you need to get to 7 1/4. So 4 plus what is 7 1/4? 3 1/4. Okay, so here's where this number is. That's our start. This is our finish. You'll notice that neither of these is our answer in this situation. Our answer is what is the difference between the two numbers, and the only thing, our answer is 3 1/4 plus 1/4. So we end up with 3 2/4 as our answer. The distance between the two numbers when you're adding up, you're going to find your answer up here in your jumps because you're asking yourself, how much do I have to add to get from 3 3/4 to 7 1/4? Okay? So just to review, you are not breaking both numbers apart when you're subtracting mixed numbers. Please do not do that. You are either subtracting back in chunks that make sense to you, work with whole numbers as much as you can get to them, or you're adding up in chunks and again jumping to whole numbers so that you can have some, well, basically less calculating in your brain. Okay? So these are the two strategies I want my class working on. I hope it helps other people learn. And if you have any questions, this is my email, Connolly with an O. Boys and girls in my class, send me a text or call me if you have any questions. Please try the work before you call, please. And I'll talk to you soon. Thank you. Bye.